Hello, Math 1. This lesson's on 2.g, which is solving literal equations. Now, this tends to be probably one of the more difficult topics for students in math, and not only math, but science also. So we need to make sure we pay attention to strategies on how to approach different problems. Now, there's really no set process for solving literal equations, right? But what we start with is the important literal equations to solve for Algebra 1 or Math 1, right? And then we progress into literal equations that are important for science classes like physics, chemistry, and so on, all right? So looking at this kind of approach is to highlight any of the variables, right, that you are solving for. Now, our first approach is basically to undo any addition or subtraction, right? That's our first attempt if possible. Then we look to undo multiplication or division. Now, when you see parentheses, right, everybody's going to want to distribute, but look to see, right, don't distribute right away. Okay, what we want to see is if I see something like this, I know 3 is linked to the set of parentheses or the quantity in math by multiplication. How do we undo multiplication? Division. So you could potentially just divide by 3. So sometimes when you distribute, you make more work for yourself. All right, and that's where the literal equations gets a little confusing. Sometimes it benefits to distribute, but a lot of times it doesn't. Okay, so let's take a look here. Second semester, you're going to see that solving for y is very important. Now, anytime we look at this, if I'm solving these equations for y, I know I have to get rid of 2 things, the 12x and the 4. But which one is linked to y by addition or subtraction? Well, the x term is. So how do I get rid of this x term? Well, it's positive. I know I'm going to subtract. So I'm going to subtract the 12x, and I'm going to bring it over and subtract it. Now, that tells me I'm going to bring down the 4y. And when I write the right side, I'm going to put it in standard form, meaning the x first. So negative 12x. Then I bring down the positive 20, so I'm going to add the 20. Now, all I have to do is undo multiplication or division. I'm going to divide everything here by 4. Now, simplify these. Negative 12x divided by 4 is negative 3x. 20 divided by 4 is plus 5. And we are done. Next one. First, I get rid of the x term. Since it's positive 18, I know I'm going to subtract it. I'm going to subtract it over here. Remember, you do not align the 36 and negative 18x because they're not like terms. Now, what do I have to bring down here? I have to bring down the negative 6y equals, right in standard form, it's negative 18x plus 36. Now I'm going to divide everything by negative 6. And that will give me y equals positive 3x. Now, 36 divided by negative 6 is going to give me negative 6, so I know I have to subtract it. Now, the next one, I know I have to get rid of the x term, right? Since it's positive, I'm going to subtract it. I bring down the 5y equals, write it in standard form, it's negative 9x first, then minus 40. Since it's negative 40, I subtract it, right? Now I'm going to divide everything by 5. That'll give me y equals negative 9 over 5x. That cannot be simplified, and don't write it in mixed numbers. Then negative 40 divided by 5 is negative 8, so I'm going to subtract the 8. Now, example 4. I know I'm going to subtract the 3x. I get negative 7y. Remember, we got to bring down that negative. Equals negative 3x plus 21. Now, I'm going to divide everything by negative 7. Now, when we go to simplify this, a negative divided by a negative is a positive. So that's going to be positive 3/7x. And then 21 divided by negative 7 would be negative 3. So I subtract the 3. Now remember, if your x term is negative, you're going to go ahead and add it to both sides. Now the next one, example 5 and 6. These are what we call in second semester point slope form. And anytime we see this, the first thing we do is we distribute. 7 times x would be 7x. 7 times 9 would be 63. So this is a case where distributing does benefit. Now, all I have to do is get rid of the 8 to get y by itself, add it to both sides. Y equals 7x plus 71. When I look at example 6, y plus 6 equals negative 8 times 2x is negative 16x. Negative 8 times negative 3 is positive 24. Now, how do I get rid of that 6? I'm going to go ahead and subtract it. And y equals negative 16x plus 18. So again, that is a rare case where literal equations, it benefits us to distribute. Now the next set, these are where are the problems that get more difficult. So when I look at the next one, if I have a minus f, a minus f equals q. I know right away my goal says to solve for a. So I have to get a by itself. So what do I have to get rid of? The f. How do I get rid of it? Since it's minus f, I'm going to add it to both sides. Remember, these are not like terms. So what do I just see here? I know I'm going to do q plus f. Okay. Now, looking at the next one, AG equals 6, and they want us to solve for A. Well, what operation are A and G linked by? Multiplication. How do I undo multiplication? Division. So what do I have to get rid of? G, which means I'm going to divide both sides by G, and I would get A equals 6 over G. Now, number 9 says solve for B. So a lot of times, if I cover up this side and I look at that, I'm going to rewrite this problem as B over F equals M, right? And the reason I do that is sometimes it's easier to move things from the left to the right. So now I look, B divided by F equals M. I have to solve for B, so how do I get rid of F? Well, if these are linked by division, to get rid of any denominator, all I'm going to do is multiply. Those would eliminate, right, or cancel out. Multiply this side by F, and I get B equals M times F. Number 10. If I look at this, I'm here to solve for B. Guys, so this is where like you wouldn't want to distribute for the simple fact that, right, B is linked to that quantity by multiplication, right? So how do I undo multiplication? Divide. What am I going to divide by? This whole quantity, D minus 4G squared. Divide by D minus 4G squared. And right away, I know B is equal to Q divided by D minus 4G squared. And there's your answer. Now the last one. When I go to solve for A here, I'm going to rewrite this problem as negative M plus 1/8 A, or sorry, RA equals capital G. Now, the first one here I'm going to get rid of is the M. How do I get rid of it? I'm going to add the M. That would give me 1/8 R times A equals G plus M. Now, earlier this semester, we said if you don't like fractions, get rid of them. So what could I multiply this fraction by to get rid of it? I can multiply by 8. Now, remember, if I multiply that by 8, I'm going to multiply everything by 8. These cancel out, and it leaves me with R times A equals 8G plus 8M. Now, if I'm getting A by itself, I have to get rid of R since it's linked by multiplication. I divide. And A equals 8G plus 8M all over R. Now, in this step too, a lot of times, like you'll see people, right, when they multiply by 8, you'll also see people do this, where they don't distribute the 8, they just multiply that sum by 8 and then divide by R. So another possible answer would be something like this. Okay, so again, work smarter, not harder with these, and work backwards. Okay, go ahead and do the student practice worksheet and let us know if you have questions.